To introduce our organization, at AI4, we organize conferences focused on how artificial intelligence and machine learning are impacting various industries. Our next conference is the AI4 Healthcare Conference, coming up on November 12th and 13th, right here in New York City. I hope to see some of you there. If you want to learn more about us, head to ai4.io. As your host today, I'm going to try to keep this webinar as interactive as possible. To that end, we'll be conducting a couple of polls throughout the webinar where everybody who's here will answer a question and then we'll show the results live. We'll also be running a Q&A at the end of the webinar. So please send in your questions as they occur to you by clicking the Q&A button, and then our speakers will address them at the end of the webinar. Now, without any further ado, let's get down to business. For today's webinar, we've partnered with Qubole, which is a Santa Clara-based company that provides a cloud-native self-service platform for AI, machine learning, and analytics. Today's webinar is called Modernizing AI and ML Operations to Rapidly Advance Healthcare. You heard that right, folks, rapidly. So if you're here looking to slowly advance healthcare, this isn't the webinar for you. Now, it is my distinct pleasure to welcome our first speaker, Pradeep Reddy.
Hello, everyone. Hi, Michael.
Welcome aboard. So before you get into the presentation, as promised, Pradeep, I have to ask you, can you please share a fun fact with the audience?
Yeah, sure. I love doing home automation, so I kind of do it from the soups and nuts. So I play with my Raspberry Pi, and I have some sensors at home, like proximity sensor, which I use to do some cool home automation projects. So I did one project in my media room, which kind of whenever a person enters the media room, everything turns on. So it's just a fun project. So yeah.
That's awesome. Yeah, Raspberry Pis are great. All right, Pradeep, well, I'll let you do a self-introduction, and I'll get out of here. Enjoy, everybody.
Awesome. So I'm Pradeep Reddy. I'm a solutions architect at Qubole. I've been with Qubole for more than 18 months now. In my prior life, I have worked 11 years for a life sciences company called Quest Diagnostics. And I've enabled healthcare solutions, ranging across a wide spectrum of application development to big data applications. So that's about me. And I'm excited to be here talking about leveraging AI and ML in advancing healthcare. And I'm joined by my colleague, Ojas Mule, who is also a solutions architect. So without further ado, let's get started. Let me start sharing my screen and we'll proceed. Michael, are you able to see my screen?
Yes, you're looking good, Pradeep. Looks good.
All right. So without further ado, let's get started. So to start with the agenda of this talk. This talk is broadly divided into 3 sections. In the first section, I'll be talking about the state of enterprise data science in healthcare. And in the second section, we'll be covering certain customer data science examples across the healthcare verticals that we serve. And in that, we will cover certain case studies. One of them is in the provider space. And the second case study is a robotics company who is trying to leverage ML and AI to advance their use cases. Towards the end of this talk, we will be leading you into a demo of a real-world example application of drug discovery through deep learning. So let's get started. So to start with an interesting story, I'll take you all back to 1854 London. Back in the day, there was this wide outbreak of cholera. So back then, cholera was believed to be caused due to bad air. And this theory was otherwise known as the miasma theory. So if you see Dr. John Snow, who is on the right, he's a physician who refuted this miasma theory. And he came up with an ingenious idea to mark on a map of London all known locations of death caused by cholera. So he took this map of London, went door to door, and he made his observation. So if you see the map, right, each mark on the map is a case of death caused by cholera. He took these observations back to his drawing board, and he made a bold conclusion that cholera was not really spreading due to bad air, it was really spreading due to water. So his justification came from the fact that the stacks of death on the map are really tracking really close to the water pumps across the board, across the map. So he took these observations back to the civic authorities, and finally the civic authorities were able to contain the cholera back in the day. So this really marked the first application of data mining and data science in the field of life sciences. And this led to the birth of a separate field of life sciences called epidemiology. So epidemiology, the field of life sciences, is more about data than about life sciences, if you heard about that. And this map, ever since, has been referenced as the ghost map. And a book has been dedicated for this subject, written by Stephen Johnson. It's a great read if you guys haven't read it. Fast forward to today, what we are seeing today is a different landscape. We are experiencing a different kind of shift in growth. Though the population is at an all-time high, we are seeing that the growth rate of the population is trending really low. It's at an all-time low right now. And also, if you see, the general population has gotten healthier. We are living longer. So the average life expectancy is at an all-time high. So given those positives, we have certain unique challenges today. If you look at one end of the spectrum, we have an aging population, and on the other end of the spectrum, the healthcare costs are really rapidly rising. And Starbucks CEO once famously quoted that they spend a lot more on ensuring their employee healthcare than on procuring coffee beans. So it speaks volumes about the kind of problems that we deal with, the rising costs of healthcare. So these challenges really need certain compelling kind of solutions to address. And basically, all these practitioners, medicine and healthcare practitioners, are looking at leveraging data. If you look at the data, right, if you look at that infographic on the right bottom corner, human data, especially a large percentage of human data, is human health data. That data is rapidly growing. It's growing 10 times faster than the traditional business data. So how do you kind of leverage this data and solve those precise and compelling problems? Like, how do you kind of understand which mutation in the gene is causing this disease? Or why is my patient not responding to this chemotherapy? So those precise and specific questions can be answered if you kind of tap this human health data. That requires a different rigor and really requires a different field of data science called human data science. So to really execute on this human data science, I mean, again, there's a lot of challenges, right? If you see, the transformational promise of big data projects remains extremely elusive. So these are the metrics published by McKinsey and Gartner. 85% of big data projects fail to meet expectations. And more than 70% of analytics potential value today is unrealized. This is across the board, not specific to healthcare. So, I mean, being successful at big data is extremely challenging. If you look at the different kind of use cases across verticals in healthcare, be it biotech, be it pharma, be it life sciences or providers, what you see is different wide variety of use cases, but all of them have one common theme, right? What they try to do is they're trying to leverage those billions and billions of data points and solve those different and variety of use cases. And if you look at data is one piece of the puzzle, right? You also need the right tooling. I mean, you need to pick the right tool for the right job. Again, you need to embrace that choice, right? Be it data preparation, be it ensuring governance and security, be it model building, or be it deployment of that solution. You need to embrace that choice and be able to pick the right tool for the right job. And if, again, we talked about data, we talked about the tooling, And another aspect to this is leveraging the right capabilities and figuring out the right process, right? You no longer can be constrained by the limits of your data centers. I mean, they have finite capacity. You've got to leverage this infinite compute power that is available in the form of cloud and which is rapidly growing every day. And you also have to be looking at how do you leverage machine learning to solve these specific and precise questions. Machine learning is becoming ever more accessible. And last but not the least, you've got to be thinking about how do you enable that self-service analytics platform so that you can facilitate those bottoms-up use cases. Again, I'll pause there and explain what I mean by bottoms-up use cases. So typically what happens is business comes to IT with certain specific problems, and IT projects get created around those problems, right? So that's really a top-down kind of an approach. So what I mean by bottoms-up is when you enable these self-service data analytics platforms, you kind of let the business solve their own problems. They kind of vend their own data and answer their own questions. So that's really is the true enterprise transformation that everyone seeks. All the enterprises are really recognizing this trend. Ones that embrace this trend and embrace that change are the ones who are leading kind of disruptive technologies to solve these compelling and precise problems. It really establishes that embracing this change is really, really important in this day of age. So if you look at different use cases across different verticals, all of them really have a common theme, right? They're all trying to leverage those billions and billions of data points to solve those use cases. How do you really create a platform around these use cases to be able to deliver success and answer those precise and specific questions that we talked about? So all these different data points come at you in different velocities and different form factors. So the platform, in this particular case, we are actually showcasing Qubole as a platform which solves this particular, which stitches this whole healthcare operations. And in this particular case, Qubole is able to actually ingest all those different data points which are coming in different form factors and different velocities. And be able to provide you that choice of tooling in terms of engines like Spark, engines like Hive, Presto, to be able to execute on AI and machine learning, to be able to leverage your data, those billions and billions of data points. And finally, at the other end of the spectrum, once you're able to create models which solve those compelling problems, which answer those precise and specific questions, you're looking at how do you kind of report out? How do you kind of do business intelligence out of these solutions? So all that is possible through this kind of big data operations facilitated by a platform like Qubole. When you're doing big data or data science in the cloud, autoscaling is an essential aspect, right? When you're operating in a data center, you're really running your infrastructure 24/7. But in the cloud, you're really renting your compute, right? So it is really, really essential to optimize your usage. So as trivial as it sounds, autoscaling is really, really important. So if you look at this cluster, again, this is one of a sample Qubole clusters in production. If you look at this cluster at 6 a.m. in the morning, the cluster was really dormant. So we were trending at a minimum capacity of the cluster, which is around 10 or 20 nodes. And right around 7 a.m., we saw an increased demand for the cluster, and we immediately scaled up the cluster. We kind of sustained that cluster capacity at 72 nodes for an hour because we saw that demand for that cluster. And right around at 8 a.m., the demand has decreased, so we kind of scaled it down back to around 20 nodes. So it's an aggressive downscaling that happened at around 8 a.m. So what this really enables is all this white space that you see here is really the dollar saved. It's the cost avoided. So if you're running your cluster in an on-prem kind of ecosystem, you would run your cluster at 80 nodes all the time, right, to meet that demand, to meet that peak demand. So it's really essential to ensure autoscaling when you're doing big data in the cloud. So again, talking about the differences between doing big data in an on-prem world versus cloud, data locality is the biggest difference. So if you look at the on-prem kind of infrastructure, data and compute is co-located. The fundamental principle in the on-prem infrastructure is to bring compute to the storage. So if you look at it, right, it's really impossible to scale storage separately without scaling the compute. So if you want to scale any of that independently, it leads to an expensive kind of deployment. Another aspect to it is it's really difficult to share the data locked in HDFS across your operating units and across your functions. You compare and contrast that with the cloud operations, right? The storage and compute is separated. So it's all about leveraging that separation of storage and compute. And what you will get out of that is ephemeral clusters. What I mean by ephemeral cluster is the clusters really won't run 24/7. You will only run the cluster when there is a workload. So that leads to really excellent operational efficiency. And if you look at it, right, data can be easily shared across your operating units and can be accessed from different locations because all your data assets are really stored in your cloud storage. So if you look at the advantages of cloud, right, it leads to a lower cost. It enables that iterative and collaborative approach, and you can scale your infrastructure needs with automation. So again, if you just contrast a few of those with the on-prem world, you're dealing with a large CapEx, $1 million CapEx perhaps, and you're dealing with a finite compute capacity. So you're hitting walls all the time. Again, certain pitfalls to avoid when you're doing data science in the cloud, right? Data governance is essential. So for successful data lakes, there needs to be a proper focus on ensuring the right anonymization. You need to anonymize your data, ensure right data policies to be able to provide that well-rounded data security. You also need to be able to keep users siloed from the data. You need to allow your users on-demand access to data and analytics in order to enable that collaboration that will help you provide that a self-service data platform that will provide those bottoms-up use cases. Again, focus on ensuring time to value. Focus on ensuring delivery versus overbuilding or over-engineering. Right, all the cloud infrastructure and the platform kind of a story that we covered so far really helps you deliver that. It helps you focus more on time to value rather than on over-engineering or overbuilding things. Again, you don't need to compromise on compliance when you're operating in cloud, right? If you look at the typical kind of a solution architecture that we lay out for doing big data or data operations in the cloud, you kind of take your data in a path of curation. So you land all your data assets, all your siloed data assets in a raw or unstructured zone, and you take it down the path of curation. You take it to a derived kind of a zone where you ensure data governance. You refine your data sets, you blend your data sets, you try to actually get more insights of your siloed data sets. And then finally, you kind of further refine it and create this source of truth zone where you share all your data assets, your refined data assets for further analysis for your advanced analytics use cases. So again, this particular use case is what we'll cover towards the end of this session. So towards the end of this session, we'll show you, we'll kind of take you a tour of how we enable this workflow and provide an example case study of drug discovery through deep learning and Keras notebook. Again, Keras is deep learning. So we'll be demonstrating this workflow towards the end of this session. Again, this is to cover the data science workflow at a high level. So this data science workflow is from Microsoft. It's called Team Data Science Process. Team data science process is all about ensuring that collaborative and iterative kind of an approach to data science and AI. So it all starts with business understanding. As important data science is today, it all really starts with that business understanding or the problem, the specific problem that you're trying to solve. So once you understand the problem space, the business case, you move into this phase of data acquisition. So you try to understand what data you need to solve this specific business problem. And in that, this is where you spend a lot of time. 80% of your time is really spent in the data acquisition and understanding phase. So here's where you wrangle a lot of data, you kind of explore your data, you clean your data, you normalize your features, you kind of prepare your data for modeling, right? And really the modeling aspect is what helps you answer those precise and specific questions. So you look at your historical observations and you help create these models which answer those specific questions we talked about, like how do you kind of help a physician understand why my patient is not responding to this chemotherapy? Or how do you help a physician understand what mutation in this gene has caused this particular disease, right? So those precise and specific questions are answered by doing this modeling and tapping those billions and billions of data points. So in this phase, what you end up doing is you do a lot of feature engineering, you do model training. Again, you try to evaluate a lot of algorithms. There is no one master algorithm. You also spend a lot of time doing model comparison, evaluation, cross-validation, all those fun aspects to modeling. And once you actually pick a successful model that is able to solve your problem in a compelling way, then you're ready for deployment. When you're ready for deployment, that's when you really productionize those models and put it behind a web service and be able to answer those questions in real time, right? Those compelling and precise questions in real time. And again, this is an extremely iterative process. So, one team can work on data acquisition and the data science team can parallelly work on modeling. So it's an extremely iterative process. You kind of jump back and forth in that circle. So it really enables a successful data science workflow. So at this time, I will lead you into a poll question, and I will also hand this off to my colleague, Ojas, to take you through the rest of this presentation. Thank you for listening. Ojas, take it over.
Yeah. Perfect. Thanks, Pradeep. So just a quick introduction, quick information about me. So my name is Ojas. I'm a solutions architect at Qubole. And prior to Qubole, I worked at Amgen, a biotechnology company, for close to 9 years. So pretty familiar with some of the challenges in healthcare industry overall. And what I wanted to share today with you is more around some of the use cases and examples of how customers are leveraging the Qubole platform and the cloud infrastructure in the healthcare field. Right. Sorry. So just to recap what Pradeep mentioned, right? So we have seen a lot of organizations moving from on-prem infrastructure to cloud infrastructure and really bringing value to their users. So one such example is a Fortune 500 healthcare services company. So this company builds technology solutions for its customers. You can imagine these customers to be pharma or life science companies or insurance providers, right? What they do is they basically ingest vast amounts of data, and some of this data could come from third-party providers. So they are able to ingest vast amount of data, which comes in different shapes, sizes, and formats, right? And then curate and process that data and also conform that data with a master data management tool, right? So they are able to really extract valuable data and curated data and then provide that data to their customers in the form of reports, visualizations, or even in some cases, just a pure curated data, which they can run and evaluate or get value out of it, right? So this organization started on the commercial side of it, where the data was payer data or pay data, or even in some scenarios, the drug sales data, right? And what they were able to achieve with this solution is really make it accessible to a lot of customers through a HIPAA compliant platform. In terms of technologies, one thing they made a decision on is really leveraging the right tool for the use case. So for the data processing, they leveraged Hive. And for some of their modeling cases, they are leveraging Spark. It is really exciting to see that how this organic growth happens within the organization. So they started leveraging these learnings based on the commercial data, and they are now using it on the clinical side of the organization and really using the modeling and the AI capabilities around it. So another such example is Auris. So for those of you who are not aware, Auris is a robotics company which builds robotic instruments for medical intervention, right? So as you can see, they have a lot of sensors on these devices which collect which collects a lot of data points, right? So there's a steady stream of data points being captured by these devices. And they needed a way of really capturing those data points, processing it, and providing value or understanding insights into it. So in this case, they were able to process these data on a near real-time basis and provide the input back to those robots to take the next action of it. So this was just an example of how you could use the real-time data for processing. They were also able to build maintenance schedules based on the data they captured on these devices, right? It's very difficult to have or process such large amounts of data on your on-prem infrastructure. And I think Pradeep did mention about decoupling and storage and compute. So just imagine what kind of infrastructure you would need if you still have the storage and compute together. And I think that was one of the key decisions and enabler for them. One good thing so basically what they are doing right now is they are really using that data and the insights to build new R&D use case. So it has really helped them in advancing the R&D pipelines and building new products around it. So that data they have really unlocked the value of the data to leverage it across data science. In terms of technologies, they are using a variety of technologies. So they decided to leverage Airflow, which is a scheduling engine, which is available as a part of Qubole as well. And then Tensorflow, which I'm going to show you as a part of the demo. So just think about how you can leverage or use some of these modeling capabilities as part of life science workflow, right? So what I'm going to show is talk about a deep learning example which uses TensorFlow, which is one of the technologies provided by Google for AI and machine learning. But just before I go there, I know this might be repetitive for some of you, but just wanted to quickly touch on what machine learning and what deep learning is, right? So machine learning can be categorized into three. Supervised learning, which includes a known or a training data set. You can think of it as an image recognition machine learning. This is an initial set of images for which you know what those objects are, right? So that's the initial training data set which you would provide to a model. And based on that, you can train the model for learning. So supervised learning is what I'm going to show you today as a part of the demo. And this is mostly used for classification type of examples. The second type of machine learning is unsupervised learning, as you can assume by the name. We do not provide any labeled inputs or the data is not identified initially. As the machine learns, it extracts features based on that input and tries to identify pattern around it. So it does not have any supervision around it, right? And the third piece is semi-supervised, which obviously is a combination of supervised and unsupervised learning, wherein you have a fixed set of data. So what's the real difference between machine learning and deep learning, right? So when we talk about deep learning is an extension of machine learning where it simulates the artificial neural network, right? So don't worry about all the mathematical calculations you see here. What I wanted to highlight here is deep learning involves multiple layers through which the data passes. And in each of those layers, it tries to extract different features based on the input and output values, which can then lead to and help you identify different patterns of those input, right? So some of these, so you can see those individual components. Those are neurons which take an input and provide an output. And as the data passes through this, it will extract different features around it. Okay. So coming back to the example which I'm going to show. So some of the key things which it wants to identify and understand is, so by the way, this is a data set provided by Kaggle, and on Kaggle website, the data is provided by Merck. So what they wanted to identify as a part of this data set is how can we accurately predict the efficacy and safety of drugs or the molecular activity of a chemical, right? So they initially started with a molecular training data set. Based on that data set, we pass that as an input to the learning model, which was then trained based on this data set to extract some of the molecular properties. So now what it means is when you have a new molecule in development, you might be able to leverage the same model which is trained on the known data set to extract some properties. So it's the whole idea is around leveraging in supervised learning is to extract some of the features and then leverage it for new models. So I'm pretty sure most of you have seen a lot of technologies out there in the market who are really trying to help in building this artificial neural network, right? So I'm going to focus on some of the technologies which I use as part of the example, but Google, Microsoft, different organizations are really investing heavily in building these technologies as a part of it, right? So one of the pretty popular and well-known framework is TensorFlow, which is used for building deep neural networks, right? So it is considered as a backend technology for artificial neural network or deep learning. So Keras, which is a high-level API which sits on top of TensorFlow, just allows you to make those API calls and make it easier for you. So it's considered as a front end to the TensorFlow. Right. There are other technologies like CNTK and Theano which can also run underneath using Keras. Right. The other piece is the Spark data processing engine. So again, you can imagine the amount of data you have. This is in petabyte scale, right? So you really need a processing engine which can handle petabyte scale of data. So Spark definitely provides that capability. And it also provides something called as Dataframe, which allows you to transform the data quickly. Right? And I'm going to build this example on Qubole, which is a self-serving AI and machine learning platform. Right? So with this, you should see a poll coming in. All right. So while you're answering the poll, I'll switch to my development environment and walk you through the drug discovery example. Right. So what you're seeing is Qubole's platform. And what I'm leveraging is Qubole notebooks. You can think of Qubole notebooks as an IDE for application development, right? So this is just a place where you would write your code, and then it would basically run on a cloud infrastructure, right? So in this case, this notebook is attached to a particular cluster, which you can think of as a cloud infrastructure. And this is where all the auto-scaling happens. So as a user, I'm not really concerned about where it's running, how much infrastructure I need, and how I can manage it, right? So I think that's what Pradeep had shown earlier. So a quick walkthrough. What I'm going to do is a quick walkthrough about this notebook and some of the visualizations which come with it. So the first thing as a part of any machine learning exercise is loading the data, right? So you would load, as Pradeep had mentioned, ingestion is one of the key aspects of it. So you ingest this data from different data sources, and you can have it in an object store. So in this case, I'm storing it in an S3 location. And as a part of this piece of code, I'm going to read that into a Spark data frame, which will allow me to kind of process that data. Right? The next step is, given that this is a sample data set, I'm going to distribute it into two pieces. One of them will be a training records, and some of them would be testing records. So I'll use the initial training records to train my model and then verify the model based on the testing record. So as we are training the model, we'll also do feature extraction, right? So what it means is, as the data is moving through the different layers of an artificial neural network, we'll try to extract some of the features and evaluate those. So as I mentioned, there are APIs. So Keras is an API which allows you to build that model. So in this case, I'm passing some of the parameters to the API, right? So one of them is neurons, which are basically the computation units which you saw in the earlier slide, right? I would define how many neurons I want per layer. The second is a learning rate. How fast do you want the data to move through your neural network and process it, right? The batch size, during each iteration, what is the batch size you want to submit? And then there are some other features around activation or optimizers, which are different functions you can use to define and build your model. So as you can see here, this is my Spark data frame, and I'm kind of just displaying all the parameters or variations of the parameters which I have as a part of it. So the next piece which I wanted to talk about is this whole notebook has one key function, which is the training function, which will basically train the model. And this is the core of the notebook, right? It takes a bunch of parameters, which we have already defined at the top, right? Like the batch size, the optimizer, your input and training data set. And then it will basically run that model and provide you a final score on the data, right? So this is where the training of the model happens, and it extracts the final score. What we then do is, based on that, once the model is trained, we'll basically run different kinds of search algorithms on top of it. So you could either run random search. There's another option of grid search, which is basically an exhaustive search throughout the network. So in this case, I'm just running a random search, but definitely grid search would provide you more exhaustive information, right? Once I have that, I would basically rank all the variations of my model. So as you can see, I have multiple different types, different values for the parameters, and then the scores identified as I train the model. In the end, I'm just trying to figure out what are my top 3 models, and then grab the top model out of it. So one other thing is, while this model is being trained, you can even visualize it as a part of the training, right? And for that, TensorFlow supports TensorBoard, which is a visualization on top of TensorFlow, which will allow you to view how the model is being trained, right? So in this case, I'm grabbing the topmost model and rerunning the topmost model and visualizing in TensorFlow, right? So as you can see, I'm just going to save the model in the end and then run TensorFlow as a part of it. So let me switch to TensorFlow. Right. Perfect. So this is what you would see as TensorBoard. So again, this is provided by Google as part of the TensorFlow and TensorBoard framework. But what you can see is, you can see the different learning patterns which happen as you move through the artificial neural network, right? So this is one example of a loss function which you can track and visualize while you're moving through the pattern. You can also look at some of the graphs which are provided as a part of it, right? So not going to go into the details of it, but what this allows you is, so in this case, just a quick overview of it. In this case, I had different components being passed to the neural network, and then each time it was being trained. So you can look at the training set of each of them and see what was the value of a loss function and different kinds of input, right? So gives you a full overview of identifying those values, and then you can use them for tuning your model. So I hope this helps you to at least get an overview of how you can build machine learning models for your life science use cases, right, and leverage it as a part of it. So with this, we'll open it up for questions.
All right. Thank you, Ojas. Thank you, Pradeep. So we had a couple questions come in. If anyone else has any more questions, now would be the time, or forever hold your peace, one of those scenarios. We'll give it a couple minutes. But yeah, thanks so much to Pradeep and Ojas, and thank you to our partner Qubole. You can check them out at qubole.com. That's QUBOLE.com. Com is spelled C-O-M. Let's see, any questions? It looks like the answer's no questions. Well, that is a wrap. I'm Michael Weiss, signing off from Brooklyn, New York. Stay neural out there. Hopefully that worked. All right. Thank you, Ojas. Thank you, Pradeep. Oh, wait, we have a question that just came in. So, oh, we have a few questions. Wow, now you guys are speaking up. It's just like in the church, you know.
Okay.
So yeah, go ahead, Ojas.
Sure. So I think the question is, what does Qubole do, and do we provide the models, right? So just to give you a high-level overview, we provide a big data platform for different use cases. These could be your AI ML use case for sure, but also for building data pipelines for ad hoc exploration as well, right? So it's a different platform. It's a single platform for all kinds of use case, and we provide different open source tools like Spark, Hadoop, Presto as a part of this platform. And in terms of models, so we do support all the open source models which you can plug in, but we don't have out of the box models. But yeah, you can definitely bring in different models which are available as a part out there in open source community, and then plug it in through a Qubole platform.
Ojas, I'll take the dimensionality reduction question. So again, like Ojas said, we don't provide the models. We provide a platform which will help you do the models. So to help reduce the dimensionality, there are algorithms like PCA, principal component analysis, which will actually compress your dimensions and get your dimensions into a lower dimension kind of. It will just compress a lot of dimension into a few important dimensions. So you can leverage those kind of algorithms to reduce your dimensions. Again, machine learning suffers with a problem called the curse of dimensionality. So that's a really, really compelling problem. But there are ways to solve it.
All right, no open questions. We're going once, going twice, going thrice. I'm Michael Weiss. Just worked out that way. Goodbye, everybody. Thank you, Pradeep and Ojas, and thank you, Holden, for answering questions. We'll send a follow-up email, and you can get in touch, with anyone at Qubole or me, whenever. Godspeed, everybody. Have a great week.
Thanks.
Thanks, Michael.